There are a few places on Earth where the night sky still looks like the one our ancestors might have gazed at when night lighting was not so widespread. On such a clear and moonless night, about 6,000 dots sparkle against the pitch-black sky. The pattern they display is hardly changing. It revolves across the sky during the night and comes back almost identical the day after. To the naked eye, a dim white streak is visible across the sky, the Milky Way. A few bright dots wander across its pattern, the planets. Every civilization has carefully studied night skies and drew constellations to better remember their shape. They use them as guiding and location beacons and inspiration for tales, myths, and legends. The first observation tool ever used was the refracting telescope, whose inventor is unknown. It was improved by Galileo, who, while it was used on land and sea mainly for military purposes, turned it towards the sky in 1609. He observed the moon and its craters in great details and discovered 4 satellites orbiting the planet Jupiter, thus demoting the Earth from the center of the universe to a mere element of it. He also noticed that some nebulae are made of a huge amount of stars, invisible to the naked eye, increasing the number of existing stars. Interpretations of these observations challenged our understanding of the world and led to a quest for technical improvements of the refracting telescope.
Il faut imaginer ces journées de janvier 1610 où Galilée, en quelques nuits, fait passer l'humanité tout entière du monde clos, le monde aristotélicien fermé, à l'univers infini avec ses myriades d'étoiles. Et effectivement, c'est la lunette, c'est l'œil de Galilée derrière sa lunette qui voit ce qu'il y avait à voir. Non pas qu'il soit le premier à observer, d'autres quelques mois auparavant l'ont fait, mais il est le premier à le voir. Et s'il est capable de voir les satellites de Jupiter, le relief de la Lune, les étoiles de la Voie lactée, c'est qu'il est totalement immergé dans la culture picturale de son temps et que c'est non seulement un grand scientifique, mais un grand homme de culture.
Observatories bloomed like in Meudon, where the largest European refracting telescope was built in the 19th century.
Bonjour, nous sommes sur le site de Meudon de l'Observatoire de Paris où il y a la grande lunette de l'Observatoire de Meudon et derrière nous la coupole de la table équatoriale. Il existe 2 types de montures principalement utilisées pour les télescopes. Il y a les montures équatoriales et les montures azimutales. L'intérêt de la monture équatoriale, c'est qu'elle a un axe qui est parallèle à l'axe de rotation de la Terre. La raison pour laquelle on n'utilise plus les télescopes et les lunettes, en tout cas pour des fins astrophysiques, c'est principalement la pollution lumineuse. La seconde raison, c'est la turbulence atmosphérique qui est due à la ville de Paris et aux activités humaines ici.
In parallel to the refracting telescope, a new device was created, the reflecting telescope, where a mirror is used to collect the light. Newton first demonstrated it in 1672, and the telescope sizes have been increasing ever since. Larger mirrors provide larger magnifying power, but more importantly, they collect more light, allowing dimmer objects to be observed. Diameters grew from 6 inches for Newton's prototype to 1, 2, and now it is 10 meters. They are set on mountain tops, where atmospheric conditions are optimal throughout the year, like in Cerro Paranal, Chile, home of the VLT, the European Very Large Telescope. A better perception sometimes comes from a different way of seeing. Only a tiny fraction of electromagnetic waves is visible to the human eye. That's why astronomical observations can also be conducted in X-rays, providing a different insight than visible imaging, just like X-rays are used for medical scans. The trouble is that the atmosphere blocks the X-rays from outer space, as it absorbs almost every kind of electromagnetic waves, except visible light and radio waves. So many radio telescopes are built, gigantic antennas listening to cosmic radio shows. Since the atmosphere interferes, just go above. So the spatial era began, starting with stratospheric balloons and airborne experiments before the first astronomical satellite facilities were launched. IUE for the ultraviolet in 1978, IRAS for the infrared in 1983, ROSAT for X-rays in 1990. And of course, the most famous of all, the Hubble Space Telescope was launched in 1990. Nowadays, new space-borne missions still monitor the sky in domains that can't be observed from the ground. Galax observes UV-emitting star-forming regions in remote galaxies. XMM Newton and Chandra, in X-rays, detect million-degree hot gas bubbles, which are the remnants of supernova explosions and very energetic phenomena, while Spitzer reveals in the infrared light emissions of the coal dust surrounding young stars or present in galaxies. Combining images of a single object taken with different instruments allows a better understanding of their nature and of the phenomena taking place. The Crab Nebula is a supernova remnant, the relic of a massive star that exploded in the year 1054. The visible images show a shell of filaments, the remains of the exploded star's atmosphere, which is still expanding. The X-ray images show the inner regions of the nebula, where energetic processes are powered by a pulsar, a fast-rotating neutron star left by the supernova explosion. A disk and jets can be seen around the pulsar. Yet, Earth-based telescopes have not been made history by satellites. The VLT is a group of 4 8.2-meter diameter telescopes whose light can be combined by interferometry to reach unprecedented levels of details. And stargazing remains a rare and free pleasure. Happy 2009 International Year of Astronomy!